Welcome to my channel. So today's topic of discussion is watering trees and watering trees effectively. Now, a lot of people use drip emitters to water trees, and drip emitters could be more efficient at doing the job. And the device I'm going to show you is how to make them more efficient. The drip emitters evaporate off from the sun and from the wind huge volumes of the water that they are trying to put on the ground, because a drip emitter drops water on a surface and then gets it wet, and it has to get it wet, and then the water can penetrate through the surface and go deeper. That takes a long time and is not as efficient as it could be for a tree or a bush or a shrub or whatever. This device is not designed for things like grasses, unless they have really deep roots, like rye. It's not designed for ground covers. Ground covers are looking for surface water, not deeper water. So this is designed specifically for trees and bushes. So when agriculture uses drip emitters for their trees, they're not efficient enough for the tree. Most people do not realize that the tree's drip line, the edge of the tree's drip line, is where the tree is getting a huge amount of its water and absorbing a huge amount of its water from the drip line of the tree, the exterior leaves of the tree. That falls down and waters a very short distance of tree roots that are prostrate across the ground underneath, just barely under the soil, within the first 6 to 8 inches, roughly, give or take the tree. And they can be deeper. They can be shallower. It depends on the tree. But for the tap roots, and deeper roots are going for deeper water in the drought times, you need water far deeper than 6 inches. And this is how you do it, because drip emitters don't do that. They don't penetrate that deep. So the device I'm about to show you, professionally made by a large corporation that's doing an excellent job and produces a very high quality product. I am not in any way dismissing the value of their product at all. If you want to use their product, it will work great. They're really well designed. They're very, very high quality. The difficulty is they're really expensive. They start around $8 for a small one, and they go to $15 for a large one. And if you're doing large acreage or broad acreage, that just becomes unaffordable. For 1 tree or 2 trees, it's okay. You don't want to put the effort in, great, wonderful. It's a perfect product. You got plenty of money to burn, and you just want to install the system. They work great. No hassles, easy to install, designed for it. If you're on a tight budget, you have low money, you have large broad acreage where you have to water a lot of trees, and you have to mitigate your costs because you're a business, you have a tight budget, this is the way to do the exact same thing less expensively. So right here is a polytube, a PVC polytube. Now I've selected 3/4 inch for myself. You can use 1/2 inch, 3/4, 1 inch, all the way up to 2 inch poly pipe. You can use any size pipe you actually want. They all work roughly the same. I selected out 3/4 because it's easy for me to handle, manipulate, and adapt. 1/2 inch becomes hard to punch these holes, and 1 inch is too expensive for my requirements. So what you see before you is roughly 1 foot of poly pipe, not exactly perfect in measurement. These are 1/4 inch holes, and they pass all the way through. They don't have to be 1/4 inch. You can use 3/16, you can use 5/16, you can use 1/2 inch. Doesn't matter. They're just a way to get water out of the pipe. The bottom of the pipe is not closed, is not sealed, okay? This is what gets pushed into the ground. On the top, you're going to notice that there's 4 inches, roughly 1 hand's width of distance where there are no holes. No holes up in one hand's width. And you don't have to be precise. There's no requirement for measuring tape on this. And then there's the cap. Now the cap is just a slip cap. It just slips on. There's no threading on the cap. And there's no threading on the pipe. They just slip together very simply and easily. Okay? This doesn't have to be tightly sealed. It just has to stop water from evaporating. Then we have a drip emitter. Now this drip emitter in specific is a 4 gallon per hour drip emitter. Now 4 gallons an hour is a lot of water for a drip emitter, okay? A lot of them are in half a gallon an hour, 1 gallon an hour, 2 gallons an hour. But if you want that water deeper, you've got to go a little bit more for a tree. You can see this is 1/4-inch poly tubing, and this is my supply line, and this is my emitter line, okay? So the reason I selected this particular emitter is because I can insert the emitter, and I'm going to use a length of at least 4 to 6 inches into the pipe. I can insert the emitter very easily if I have a little bit of control, not shaking. I can insert the emitter very easily into the pipe, and it's a 90-degree turn. And I like that because then there's no flex in the line, there's no strain on the line. The line doesn't have strain on it to get into the pipe. Then the line can be placed anywhere. Normal drip emitter line. Okay. Other drip emitters like the circular type can actually go in the tube. I just don't prefer that. This does not have to be here. This can be poly pipe all the way here, and you can bend it over and shove it in. This emitter can be back at the larger supply hose. That's fine, whatever. I like it here because then I can see the drip emitter working. I can pull it out. I can test it to see if water is coming out of the end. And so for me, it makes it really easy to walk around the property and pull an emitter and say, yeah, the emitter is working. Everything's working up until this point. This is a flag emitter. I don't prefer flag emitters. I prefer circular emitters, but I can't get one in 4 gallons per hour, so flag emitter is it. Okay. That being said, how much did this cost? We have a few parts. We have the tube, we have the cap, we have the poly pipe, the 1/4-inch poly pipe, and we have the emitter. And that's just this one device. And we're going to do dozens of these on a property or more. So for 1 foot of PVC 3/4-inch pipe in 2023, right? The end of 2023, this was 1 foot of this is 48 cents a foot, rough, plus tax. Okay. So, that's not very expensive. The poly tubing, this stuff, is 9 cents a foot. Okay. So not very expensive unless you're doing huge broad acreage. The cap, the PVC cap is 40 cents for the PVC cap. Oh, excuse me, sorry. 82 cents for the PVC cap. It's 40 cents for the emitter. So let's go over those numbers one more time. 48 cents per foot. 1/4-inch poly tubing, 9 cents per foot. Drip emitter, 40 cents per drip emitter. Cap is slip cap is 82 cents. So the total rough cost of one of these is roughly $1.79 plus tax in your local area. Okay. The other device that's being sold at really high quality, manufactured, you don't have to put any personal energy or time or labor in, is $7 to $8 to $15 per unit. So we can do $1.79 per unit or $8 per unit. So this is 1/8 the cost of a professionally designed unit, and it will work the exact same. In here, you can fill this pipe with sand or aggregate like pebbles, rocks, whatever. to keep it from clogging with clay and fine sediments when you drive it down into the ground. So what happens with this is that we take the cap, and you can drill the hole after you pound it in the ground if you want. It's not a big deal. If you pound on it, you might have to re-drill the hole a little bit. Again, not a big deal. You slip the cap on, right? And this is designed to come back off if you can ever get it off. Sometimes they get tight. But when it's in the ground, you can pull the whole device up. You can pull this whole device up and then put it back in the ground. It's not a big deal. Just a little bit of labor if you're concerned about clogging. You take the pipe, you put the cap on the pipe, you take a hammer, which I don't have with me currently, and you get this as deep as you can in the ground. Remember, there's 4 inches on the top that's not got any holes in it. And you're going to drive this down. Bam, 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 until it's about there. So my hand, imagine my fingers are the level of the soil, and the cap is right at the top of the soil. So it's not super obtrusive. Then you take your drip emitter with your outgoing water, and you just slip it in there. And you set it down. Now, I put about 4 to 6 inches of 1/4-inch polytubing deep in the hole so I can get the water deeper. You can do less, but I prefer longer. It's just my preference. It's not a requirement. But for $1.79 plus tax, highly effective. The cap keeps the water from evaporating inside the tube because there's 4 inches of depth initially for water to have to get down. It's going to go deeper automatically. The water is going to go deeper automatically. And then it has to come up 4 inches to evaporate. So 4 inches of soil above your water, you're not going to get any sun heat of any particular nature. Sun heat doesn't usually go below a few inches. Solar radiation. Fire doesn't really do it either. I mean, this would burn in a fire, but that's not the point. So heat doesn't usually travel down very well. Usually heat travels up really easily. Cold travels down, heat travels up. So 4 inches below the soil line, and you're reducing your evaporation rate by something like 90%. So you can use 10 times less water to get the same job done using a device like this for a tree at deeper root level. I selected 1 foot. You can go 2 feet, you can go 3 feet, you can go 4 feet. Depends on where you want to water the roots or how deep down you want to get your water. These are really good to install when you install a tree. You can install them afterwards, but you have no idea where you're pounding this through to and if you're going through a root or other structure. So I prefer to install these with a brand new tree install. When I plant a tree, I want one of these in. Again, I just used 1 foot of PVC as a demonstration. It's not a requirement. I could have gone 6 inches and it still would have worked because I'd have 2 hole sets roughly. It's not that big of a deal. I could have used a 1 gallon emitter instead of a 4 gallon emitter. I could have used a 1/2 gallon emitter instead of a 4 gallon emitter. I prefer 4 gallon emitters for deeper water penetration for the tree. But I can use less, I can use more. It's totally up to me as a designer. So for $1.79 versus $8, we're almost saving you 7 times the value, 6 times. So let's call it just 1/6. This costs roughly 1/6 the value of purchasing a very good high quality product. But how many of these can you produce per hour? This is a very economical way to help establish trees, along with installing swales, using compost, using mulch. So imagine that this is the ground layer. This is the mineral soil layer that you have. If you can add 3 inches of humus material, you can capture 1 inch of rain for the year. So 3 inches captures 1 inch. Well, then 6 inches captures 2 inches. 9 inches captures 3 inches. So how much water do you want to save for your orchard or for your tree so it can produce all on its own naturally. It depends on how creative you are. This, pretty good. I like it. Have a great day.